हेलो एवरीवन, कैसे हो आप लोग। माई सेल्फ चेतन गर्ग, आई एम मास्टर टीचर here at Vedantu. I welcome you all again to our RMO Flashback series. In today's session, we will be discussing question number 3 and question number 4 of year 1993, right? And before starting our session, I'll give you one information that currently here at Vedantu, we are running pre-RMO, RMO and INMO batches. Those people who have not appeared for pre-RMO or unfortunately have not cleared pre-RMO yet, they can simply visit our website olympiad.vedantu.com, right? Here they will get each and every information regarding pre-RMO batches, and those who have already cleared pre-RMO or RMO, we will directly enroll you to RMO and INMO batches respectively. That is, those who have cleared pre-RMO, they will be directly enrolled to RMO batches, and those who have cleared RMO, they will directly enroll to INMO batches. All you need to do is just mail me your name, class, your contact number, your address, along with the proof that you have already cleared these exams on this email ID, right? chetan.garg@vedantu.com. We will directly enroll you to the respective batches. And the most important thing is that these courses are totally free of cost. You do not need to pay any even a single rupee to enroll in these batches, because the ultimate goal is to bring gold for India, right? So let's start our session. And this is the question number 3 of year 1993, right? And those people who have not solved, even who have not tried this question yet, I'll really encourage you to please take your time, just pause the video, पहले इस क्वेश्चन को सॉल्व करो, है ना? Then if you are still not able to solve this question, then you can come again and watch the solution, right? Okay, I am proceeding with the solution, right? So this basically is a question of combinatorics, permutation and combination, right? The question says that there is a 20-sided regular polygon, right? How many non-isosceles triangles, take a non-isosceles scalene triangle, can be formed whose vertices are among the vertices of the polygon, right? But whose sides are not the sides of the polygon, ठीक है? तो पॉलीगॉन की साइड वर्टिसेस पॉलीगॉन वाले वर्टिसेस लेने हैं, बट साइड्स पॉलीगॉन की नहीं होनी चाहिए, राइट? एंड ट्राइंगल शुड आल्सो बी नॉन आइसोसेलेस, ठीक है? तो कुछ कंडीशंस इसमें दी हुई है, ओके। तो ये जिन्होंने परम्यूटेशन एंड कॉम्बिनेशन अच्छे से किया हुआ उनके लिए काफ़ी इजी क्वेश्चन था, ठीक है? तो लेट्स स्टार्ट विद द सॉल्यूशन. लेट्स फर्स्ट ड्रॉ अ रफ पॉलीगॉन, राइट? Okay, I am not drawing a 20-sided polygon. I have just kept this open, right? So first of all, we will find the number of triangles whose vertices are the vertices of the polygon, but whose sides are not the sides of polygon, okay? And we will then subtract the isosceles triangles from that figure. That will give us the non-isosceles triangle, right? So how many total triangles will be there? Total triangles will be 20C3, right? Because there are 20 points on the regular polygon, है ना? But some of these triangles will have the sides common as that of the regular polygon. Now we will subtract those polygons which have sides common, right? So there can be basically two types of triangles. One triangle which will have two sides common, like this, right? Okay. So first of all, we will subtract these type of triangles, okay? So one triangle is this, one triangle will be this, right? So every two consecutive sides will give us one such triangle, okay? So how many triangles will be there? There will be 20 such triangles which have two sides common. As you can say, इस side के corresponding एक बनेगा, है ना? And इसकी corresponding एक. If we rotate this, we will get 20 different triangles, okay? That one last of this figure will be this and this and this, right? So 20 triangles will have two sides common. Now let's subtract the triangles which have one side common, right? Okay, let's first again draw the random regular polygon, okay? Let's assume this side is common, right? So we have already consumed two vertices of the regular polygon, and we are interested only in one side common this time. So we cannot use this polygon, this side, this vertex. We also cannot use this vertex because this will give us two side common, right? We can use this if this is the third vertex. If let's say this is the third vertex, then this will be the triangle, which will have only one side common, right? So we have selected, or we have already selected two vertices, right? And the third vertex can be selected from the remaining points except from these 4 points, right? So for the third vertex we have in fact 16 possibilities, 20 minus these 4, okay? So one such side will give us 16 triangles, right? And all these 16 triangles will have this side common. Now this side will also give 16 triangles, this side will also give 16 triangles. So in total we will have 20 into 16, right? So this is nothing but this is the triangles which have all the vertices as the vertices of the polygon, but whose sides are not the sides of the polygon, ठीक है? I hope ये समझ में आ रहा होगा. But in this question हमें एक चीज और निकालनी थी. We also have to find the non-isosceles triangles, right? तो अभी इसमें क्या होगा? It will have both isosceles and both non-isosceles, right? But we are interested in only non-isosceles. ठीक है? तो what we will do, we will subtract the isosceles triangle from this thing. ठीक है? तो that will give us the answer. ठीक है? तो now what we need to find, we need to find the number of isosceles triangles which do not have any side common with that of the polygon, right? Okay, so let's now find out the isosceles triangles. ठीक है? Okay, just tell me one thing. Can there be an equilateral triangle which have the vertices as the vertices of the regular polygon, no, regular 20-sided polygon, right? The answer will be simply no, right? Because let's assume this is the equilateral triangle, okay, which have all the vertices on this 20-sided polygon, right? So since this is an equilateral triangle, so 3 vertices have already consumed, okay? The number of points which the number of vertex which are there, that should also be there, number, and that should also be there. So the total points, that should be a multiple of 3, right? If the total number of sides or the total number of vertices of the polygon are of the form 3k, then only we can draw an equilateral triangle whose vertices are the vertices of the given regular polygon, right? But here this is not the case, so we cannot draw an equilateral triangle. ठीक है? Why I have used this concept? I'll tell you. ठीक है? हम अभी क्या करने वाले हैं? We will just find the isosceles triangle with the vertex from which the 2 equal sides are coming, right? Let's say ABC is an isosceles triangle. ठीक है? We will find the isosceles triangles considering A to be our vertex, right? Okay, so let's first draw again the regular polygon. Okay, now we are interested only in what? We are interested only in a number of isosceles triangle. Let's count the isosceles triangle from this point A which do not have any side common with the polygon, right? Okay, so since these have 20-sided polygon, right? So if there will be definitely be a point which is directly opposite to A. Let's say this is A dash, right? So if I join A and A dash, I have already consumed 2 points, right? And so there will be 9 points this side and there will be 9 points this side, right? That will make total how many points? 20 points, right? Now I want to calculate the isosceles triangles, okay? And that also whose sides doesn't make the side of the polygon, okay? And that also starts from the vertex A, right? So if I have selected this vertex A, I cannot select this point because this will form the side of the polygon, right? So apart from this point, how many points can I have from this side? I can have 8 points, right? And let's assume I have made this thing, okay? Correspondingly, I'll select the mirror image of this point from the left hand side 9 points. So that will give us an isosceles triangle starting from the vertex A, right? So each vertex which act as a vertex of the isosceles triangle, that will give me 8 different isosceles triangles, right? And in fact this triangle will not be repeated ever. Why? Because we cannot form this same triangle from this point, because in that case these 2 sides are equal, and for A these 2 sides are equal, right? that will give us this equilateral triangle. And that's why I have already concluded that in this particular polygon we cannot make an equilateral triangle. Okay, so these 8 triangles will not be repeated. And how many points are there total? There are 20 points, and each point will give 8 triangles, 8 isosceles triangles. So how many isosceles triangles I will get? 20 into 8, that is 160, right? So let's subtract this 160 from the previous figure, that is this. So the final answer will be 20C3 minus 20 minus this 320, right, minus 160, which is isosceles triangles. Okay, that will give you your final answer, and that is nothing but 640, right? So the answer to this question was 640, right? And that was a very simple question, है ना? मैं एक बार फिर से रिपीट कर देता हूँ what we have done. First of all, we have found this thing. What is this? This is nothing but the number of triangles, right? All the number of triangles whose vertices are the vertices of the polygon, but that do not have any side in common, right? So this thing will contain some isosceles triangle as well as some non-isosceles triangles. But in the question we are interested only in non-isosceles triangle, right? So we will simply subtract isosceles triangles from this thing. And how we have found this isosceles triangle? We have found number of isosceles triangles that are formed from a vertex, and that came out to be 8. So number of isosceles triangles was 160, and then we have subtracted this figure from the previous figure, and we got 640 as answer, right? So that was the question number 3 from 1993. Now let's proceed to the question number 4, right? So this is the question number 4th of year 1993. Again, this question is from geometry. The question says that let ABCD is a rectangle, with both the sides as A and B, both the non-equal sides, right? Let R1 is the radius of the circle passing through A and B and touching the side CD, right? And similarly, R2 is the radius of the circle passing through B and C and touching the side AD, right? We need to prove something. Okay, we need to prove this thing. R1 plus R2 is greater than or equal to 5 upon 8 into A plus B, right? So let's first draw the figure, right? Let's say this is A, B, C, D, right? And as you can say, this is this is a circle which passes through A and B, right? And which touches the side CD. And let's assume the radius of this circle is R1, right? So let's first find the value of R1 in terms of A and B, right? So AB is A, this side is A, and this CB is B. Okay, all right. Let's assume the center of the circle to be this point, right? So this thing will be R1. Okay, ये बहुत ही आसान क्वेश्चन है. Only a simple Pythagoras theorem followed by some inequalities, right? All right. If by symmetry, let's say this point is D, right? D we have already used. Let's assume this point to be E, right? So what will be AE? AE will be nothing but A by 2, right? This is A by 2, right? And if we let's say O is the center of the circle, if we extend EO, it will obviously touch this point. Let's say the point is F, right? So what will be OE? OF is clearly R1, so OE will be nothing but OE will be how much? B minus R1, as EF will be B, because EF is nothing but equal to CB, right? So again, using Pythagoras theorem, what we will get? R1 square, that will be nothing but A square by 4 plus this thing B minus R1 whole square. Now we can find the value of R1 from this equation in terms of A and B, and what we will get? We will get twice of B R1. R1 square will get cancelled out, obviously, that will be equal to nothing but A square by 4 plus B square, right? So R1 will be A square by 8, right, plus how much? B by 2, I guess. Yes, plus B by 2. This is R1, right? By the same logic, R2 will be nothing but B square by 8 by symmetry, plus A by 2, right? So these are the values of R1 and R2. Okay, R1 we have solved. Similarly, R2 will be this thing, right? So what will be R1 plus R2? R1 plus R2 is simply nothing but, that will be let's assume B by 2 plus A by 2, right? Let's add these two, and then what it will, okay, here it will be 8b, sorry, and here it will be 8a, right, because we have divided by 2b, right. So that will be nothing but a square by 8b plus b square by 8a, right. So this is the value of r1 plus r2 जो हमें प्रूव करनी है कि that will be greater than or equal to 5 by 8 upon a plus b, right. Okay, so one inequality was there, that is also known as T2's lemma, and that can be that is just a simple application of Cauchy-Schwarz inequality. The inequality says that if a square upon x plus b square upon y, and that will always be greater than or equal to a plus b whole square, right, upon x plus y, and the only requirement here is x and y should be positive, right. So here if we apply this lemma on this part, right, only on this part, so what we can say, that will be greater than or equal to what we can say that will be greater than or equal to a plus b whole square upon 8 times a plus b, right. So this got cancelled out. So what we have found that this r1 plus r2 that will be greater than or equal to this thing b plus a upon 2, right, and plus इसकी जगह पर we can write a plus b upon 8, and this is nothing but this is equal to how much, this thing, right, 5 upon 8 times a plus b, right. So that is what we need to prove, that r1 plus r2 will be greater than or equal to 5 upon 8 of a plus b, right. So that was a simple question, right, and this is very common inequality. You need to learn this thing. This is also known as T2's lemma, because it was given by T2 Andrescu, right, and this is a simple application of Cauchy-Schwarz inequality, right. So we have used two things. First of all, we have used Pythagoras theorem to find the value of r1, right, by using simply this thing, so that will give us the r1 equals to this, right, and similarly we have write that r2 will be just interchanging the values of a and b, right, so r2 will be this, and now for the inequality part we have used this inequality, right. So that was a very easy question, and that's a mixed question of geometry and inequality, right. So that's it from today's session, right. We have today discussed here question number 3 and 4 of year 1993, and again one announcement that I have already made at the start of the session also, that the people who have already cleared pre-RMO or RMO, or in fact if you have any other academic achievement, you can mail your achievement along with your name, your class, your contact number and your address on this email ID. Okay, we will directly enroll you to pre-RMO and RMO and INMO batches, right, and those courses are totally free of cost. You do not need to pay even a single rupee to enroll in these batches, right. So that's it from today's session. In the next session we will be discussing the next two questions of year 1993. Bye bye.